So dealing with resupply chain issues, I'm going to try and keep this very short. There's 4 of them. First one is broken resupply chain. Fundamentally, it means that you don't have a fully integrated value chain or supply chain. And if you don't have that, then you will be putting yourself one way or another into the hands of other companies or the Chinese. And I'll come back to why I'm bad on the Chinese. It's not personal to anybody, but and you jeopardize the future of your company to a certain extent because you lose some of your control and a lot of your revenue. Now what we've seen here is that broken resupply chain is not natural. It's from a market point of view, it's been disrupted for most countries and companies outside of China because they've monopolized some of the higher tech and more difficult steps in order to get to that alloy stage. So hence when it comes to the chemical separation of the individual rare earth oxides, it can be accomplished by China and only a few other labs in the world. So we have a bottleneck, a high technological bottleneck, where companies that have good resources and reserves cannot necessarily afford the technology to bring them into play. The rebalance problem relates to the fundamental difference in abundance of light rare earths and heavy rare earths. So if I need and must have 20 tons of terbium, for example, which is one of the heavy rare earths, I probably have to mine 50 times that amount of cerium or lanthanum in order to get that amount of terbium, because all the rare earths come in a lump and then you have to separate them. And what this does is causes imbalances in trade. It means that those light rare earths will always be overproduced and that their prices will tend to be, and they'll be in surplus, and then their prices will remain low. It's what we call sacrificial overproduction of certain low value rare earths, but it's fundamental. It can be solved to a certain extent when we go into higher orders of means to separate the different rare earths, but it's not common. It's not in a metallurgy textbook somewhere. This is still sitting in the hands of China for the most part. So massive overproduction of cerium lanthanum to meet end user demand for creos results in stockpiling, flooding of the market. It exacerbates the imbalance between production and demand for other rare earths, and of course it leads to lower prices across the board on the non-critical rare earths as well. Environmental impacts. Again, I'm sitting here with 4 slides and I probably have to hurry here a bit. The 2 main things that come out, first of all, when you're mining these things, the rare earths, and processing them. One is they do have natural occurring radioactive materials in it, and I already talked about that, and must be cognizant to not allow that to get into the waste products and then into the environment in an uncontrolled way. We must also mine and handle the materials properly so that we don't hurt people or the public. On the other side of that is the mineralogy of the dominant minerals from carbonatites and alkali intrusions and many metamorphic deposits of rare earths. Their environmental character as mine waste is fairly benign. Basically, they don't have those nasties in their sulfur creating minerals where you would get acid mine drainage issues or weird hex chrome abundances that might hurt people. So carbonatites in particular tend to help buffer those deleterious reactions, and So we have like a good and a not so good side to the rare earths. About the worst thing in the public's mind eye right now is the fact that with the excesses in China and the lack of regulations and monitoring, they've got literally $100 billion US dollar cleanup program in the next 10 years. So we don't want to do that. That's been seen by the public, and now there's a bit of a tarnish on the rare earths because they consider them dirty. Mines nowadays in the rest of the world, and China increasingly now, really aren't allowed to do or have those excesses anymore. So one way to alleviate some of these environmental problems potentially is to diversify supply. And this includes recycling rare earths, try to improve the economics and the processes for existing sources, identify new uses for co-products, so i.e. uses for all of the rare earths if we can. And sometimes we can use substitution of the expensive high demand rare earths like neodymium. There is research right now where they combine cerium and cobalt, and it's not as strong of a magnet, but it can certainly do the work of many of the magnet applications or uses or needs. And also to try and divert as much of the rare earth production into the better side of the usage. So it can be green energy, it's going to be your vehicles, high efficiency lighting, and the rest of that. And then the China issue. I think you've really probably understood the tact that where I'm going with this. China is a monopoly, and they've been the dominant producer since the mid-80s, basically. And we've gone through a number of different hitches in that last 25 years or so, but this slide describes a little bit of that. Sufficient to say is with the current political situation, China and the US are at odds with each other, and one of the ways to bludgeon the other is using trade weapons. And that's where restricting the export of rare earths to the rest of the world, China can effectively leverage their power. Excuse me. And the last point on this slide, just quickly, is prices of some of the critical rare earths soared in Q2 2019, likely as a result of the trade dispute between the United States and China. So it's sort of become well known in that regard. This slide is encapsulated in the red box. China sells less processed products to not less well processed, but lesserly processed rare earth products to their own internal domestic industry only, and sell high value add products to the rest of the world. So this gives you an idea of what their strategy is with their mines to market full value add chain, is to make money, to strengthen their economies by doing what most businesses want to do, is add value and sell for more money. But this has consequences certainly for companies and countries that don't have rare earths. And this is also shown in the bottom right, where we have, for China, 97% of global production. That's coming down now and will continue to come down as mines are started in particularly Africa. Of that, the separated oxides is 97%. Of that, the refined metals, when this picture was made, I mean, they've got 100% there, but there are other companies that also refine metals. but China still has the greater share of it. Alloys and powders 90%, and manufacturing 60 to 65%. So this, in a nutshell, shows the extent of their control. So this China issue is becoming the China syndrome. And for a producer bringing online a new rare earth mine outside of China in the coming years, be it anywhere in the world, there's a high probability that your rare earth mine outputs are going to flow through China's value chain at some point along that chain. This leaves you as a producer and your investors and your customers subject to situations of uncertainty or opacity where it's more for the higher agenda of China than it is for trying to assist your company or the people you're representing. This is a rather frightening chart. This is China's market share on steps of rare earth value chain. So it begins with minerals back in the mid-1980s. Then it goes to rare earth materials, which are used to construct rare earth end products. And then now, since roughly 2010, components, rare earth components, so it's refined again. And what we're just starting now is rare earth systems. So the market share value jumps from each of those four paradigms. 4 billion US for minerals, and that's in the 80s, early 90s, to $40 billion of materials in the 90s to knots, and then to 400 billion for the components, which is the stage that we're in now, and ultimately having a grip over the entire system, including everybody else's processing and value add, 400 billion US dollars worth of value. So this is not a trivial strategy by any stretch. We've already talked about permanent magnets. The drivers are, in fact, for the drivers of demand for rare earths are the end use in magnets to put into all of our high-tech gadgets. Critical resupply issues through till 2025, 2024. Because I'm just going to jump over those and come back to functionally the thesis or proposal of this talk. And that is a resupply value chain development strategy for South Africa. So can South Africa spearhead, develop, build, and support a full supply and value chain for African rare earth mines based on provision of, say, toll, separation, and metal making services, which are those higher value end steps? And as Mintek said 8 years ago, the question is really, why not South Africa? And it's a good point. We have three decent potential, rare earth deposits that have code-compliant resources in the country. And we have numerous other ones in Southern Africa. And I've listed them there. So there's 9 others besides the 3 proper in situ rare earth deposits, in addition to placer sands. These are heavy mineral sands that have a component of monazite. And right now there's no use for them there, and they're sitting there with some mild amount of radioactivity as well. But to separate that monazite out, you could probably almost double some of the output from, say, Steenkampschool, for example. So we have resources in South Africa and Southern Africa, and significant resources. So what to do with those? All of those companies that have determined those resources struggle to raise financing for high capex or high capital investment processing plants, and to try and do that without involving the Chinese, because they want to sell, for example, the United States a non-Chinese rare earth, and that's part of this trade war again. But at the point of it is, there's a shortage of money and there's a shortage of capital, and a lot of that capital is redundant. A lot of that capital expenditure on processing could be very redundant. So instead of building a processing plant that does the same thing at each of these deposits, the idea is to build a centralized rare earth facility. So basically it would be a process technology research center. There would be labs, and there'd be scientists, and there'd be a lot of research on what exactly needs to be done to emulate what the Chinese have already done, or even improve those recovery efficiencies over the flow sheets that they have. Also to develop new green energy and magnets technology. To develop a magnets technology in South Africa right now wouldn't be that difficult if we had the rare earths in the form that we need right here. And that is the highest probably value add step that there is. Now, so to do this, we would need a central facility. On that facility, we would take in a rare earth concentrate, or a rare earth carbonate, an evolved form of the rare earths, something that we could use in the centralized refinery and smelter facilities in order to separate those rare earths and convert them to oxides, purify them, and then as not in the same building, but maybe in the same industrial complex, convert those rare earths to metals, and then using specific over the board available technologies to create custom realloys. So the requirements for a facility like this would be, it's got to be world class, because you're going to be servicing anywhere from 3 to 12 different mines. You would have to develop the processing stream for each one of those, because it's usually quite specific or unique to the type of rock that the rare earths came from. We'll need governmental support, infrastructural support. We'll need advice and approvals from the National Nuclear Regulator. Government's going to help with creating trade, tax and royalty incentives. This is just a list of some of the things that we would have to do. You would also need international agreements so that you could move rare earth product or over international boundaries to get to South Africa. And ultimately, knowledge sharing with the high level metallurgical and people and scientists. So finally, there's a lot of issues against it, but I think the benefits are probably the best way to end this talk on. There are some issues, there will always be issues. So it's a matter of will and to understand the synergies and the benefits that will come. So the facility can attract world-class experts. It can work at economies of scale and costs for whatever services, toll, separation services, reagents used, processing systems, and operational support. You would centralize the necessary infrastructure in one place instead of many. And you would avoid a large amount of these capital costs, as I said, for duplicating the same kind of facility in many places. So finally, I mean, the list of benefits goes on. Social and labor aspect of it. It would improve the viability of the exploration and mining companies, because you would have certainty and know what kind of products and how much you'll get at the end of the day. And it creates a major manufacturing center of excellence. Think of Saldonnia Bay. They've got a similar concept there, but we can also extend that concept to the idea of a centralized facility or complex. So this would then provide a value rechain strategy for South Africa by Southern Africa stakeholders. And there's some pithy comments there talking about what South Africa has to add to this concept. But at the end of the day, what I've tried to show you with some greater understanding is that is the relevance of rare earths for South Africa. Thank you very much.